All right, this is the Unit 6 circles review. We're reviewing everything that we've learned about circles, and there's a lot of theorems you have to remember. Okay, so right here, number one, what is the value of x? All right, if you remember this, when it's cut, these are not in the center. Okay, so these aren't equal to one another, but you can take these two segments right here, 3 times 7, and you set it equal to, now take these two segments, 2 times x. All right, so this is 21 equals 2x. And to solve for x, we can divide by 2. All right, so x equals, you can leave it as 21 over 2, or that's 10.5 either way. All right, now, this time we're not talking about segments in number 2, we're talking about angles. All right. Now, anytime it does not cross in the center, you can obviously see that these arcs are not the same. But if I'm using this arc right here, and you can use like a highlighter if you want, this arc right here and this arc right here. Okay. I like to put arrows to say, okay, I'm dealing with this angle right here, which is angle A. I've got to find A and B. All right. But here to find A, what you do is you add the two angles, 55 plus 165, or arcs, I'm sorry, and divide by 2. Now, in your calculator, you can do one of two things. If you're using one of the handhelds, if you hit alpha and then the X button right beside alpha, you've got the fraction. So 55 plus 165, and then arrow down, divided by 2. All right. Otherwise, if you do 55 plus 165 like this without parentheses, you have to press enter and then divide by 2. All right. So A comes out to be 110. But how is A and B related right here? Okay. If you look, they lay on a line together. And what do lines equal? Lines equal 180. So when this is 110, how do we figure out B? Well, B, you can take 180 and you minus 110 and you end up with 70. So B equals 70. I'm going to circle all my answers just so you can see them. All right. And I'm just, for most of this unit, I'm doing most of the calculations just on a calculator. Okay. And that's all you really need to do. All right. Now, for this one, we want to find x and y. Now, notice these are two tangent. The definition of tangent is it touches in one point. All right. It doesn't go through the circle in 2 points. That would be a secant. So here, remember, what is an entire circle? Okay. An entire circle is 360. So if I take 360, all right, so 360, and I minus my only arc that I have, 117. All right, it's 243. So this other arc right here is going to be 243. Well, that's what y is. All right, now we have to find x. Notice it's the angle on the outside. So when we do this, we would say the far arc minus, so when the angle's on the outside, we subtract the close arc and divide by 2. All right. So again, if you're using this and you want like the fraction form, say alpha x. All right. And we say 243 minus 117 and then arrow down and say 2. All right. So you should be getting 63. All right. So this is the value of x. And my suggestion for you is, as I'm doing this, you need to be trying this too. If you want to try this in Desmos and try the calculations, please feel free to. I'm not going to go back and forth a lot, but I'll show it to you right now. So 243 minus 117. If you notice, if I just divide by 2 right here, it only goes underneath the 117. So otherwise, if you highlight it or put parentheses around it and then say divided by 2, then you do get the 63. So be careful about that and how it looks in your calculator and that you're getting the calculations correct. All right, let me go back to the page and let's continue with number 4. Okay, be careful when it's asking for 2 values. Make sure you answer both of them. All right, now, so number 3 was about angles again, and when it is on the outside, this time it's about segments, but the angle's on the outside. Still with this. Remember when the angle's on the outside and you've got segments, we say the outside times the whole thing. And the whole thing, you want to add these two together and you get 30. So the outside times the whole. So 10 times 30 equals, go to the other segment, the outside. So what's outside the circle, which is 12 times the whole. And now right here, the whole thing, don't say 12x, you add them. So it's 12 plus x. So I'm going to put it in parentheses right here. Now we can solve this by hand. I will show you solving on the Desmos if you're not, if you hate solving equations, but here we go. To solve the equation by hand, I get 300. All right, distribute my 12. So that's 144. And then 12 times x is 12x. All right, what we do is subtract 144. Okay, so when I take 300 and I subtract 144, I get 156 equals 12x. And then I divide by 12. So x equals 13. Okay, now let's go check it on Desmos. Say if you're like horrible at solving equations, but you know how to set this up. All right, so when I set it up and I can go to Desmos, all right, what I can do is I put one side of the equation. All right, 10 times 30. You can just say y equals 10 times 30, or 10 times 30 is 300, however you want to write it. Okay, and then the other side was 12, parentheses, 12 plus x, or x plus 12, however you want to put it. And now, and this goes for any type of equation. We've done this before. All right, we did it with exponentials, logarithms, absolute value, and so forth. You're looking for the intersection. So we found the intersection right here. And you want that x value right there, and it's 13. And isn't that the same answer that we just got when we solved it by hand? All right, so make sure you're using your resources and checking your answers as well. All right, let me go back. Here we go. All right, so number 5, what is the area of the sector? All right, now notice that this is in degrees and not radians. All right, when it's in degrees, you just take basically the fraction of the circle out of 360 and then pi r squared. You're going to have to know these formulas, so make sure you know them. All right, and I like to say n over 360. All right, so 51 over 360, that's the degree over 360. All right, pi, and just notice, okay, they gave me the radius. If they give you the whole line, it's the diameter. So 2 squared. All right, now I didn't say what to round this to or to leave it in terms of pi, but let's just take our calculator right quick. I'm just going to round this to the nearest hundredth. So hundredth is how many decimal places? 2. All right, so if I put this in, 51 over 360, pi, remember pi is if you, when you say the second button in this caret symbol right above the division sign, and then 2 squared. Okay, so to the nearest hundredth, it's going to be 1.78. So 1.78. And when we talk about area, this is going to be meters squared. So it's always your units squared. All right, so I've mixed up all the different reviews. So you got to remember this for your test. It gets all mixed up. All right, now number 6, anytime I have tangents, and unlike number 3 had angles, but when I have tangents and it's segments right here, these two are equal to one another. All right, so we set them equal. 2x plus 5 equal to 3x. That should be a minus right there. Minus 2. All right, let's go solve. I'm going to solve it by hand. You're welcome to put each side into your calculator and find where they intersect. Okay, but I'm going to solve by hand. So I subtracted 2x first. I like to start with the x's. Some of you like to start with the constants. All right, 3x minus 2x is x minus 2. And here, to get x by itself, do the opposite, add 2 to the other side. So I get x equals 7. Now, anytime you're talking about geometry, any of your geometry problems, and you've solved for x, make sure you go back and read what the question's asking for. Here it says find the length of JK. All right, 7's not the answer. I've got to plug this back into 2x plus 5. All right, so 2 times 7 plus 5. So 14 plus 5 is going to give me 19. All right, I'm just going to double check that. 14 plus 5, yep, 19. All right, moving right along. We're back to angles and circles again, okay? But this time we've got some special angles, all right? One of the things that you notice is, do you see how that you have this right here? What is that in the circle? It's a diameter. So it split something in half. All right. And this half is actually 180 degrees. All right. So it splits the circle in half. Half of 360 is 180. All right. Well, here, angle A. Now, you may be able to do this without writing the 180 in, but this is an inscribed angle. An inscribed angle, anytime the vertex is on the circle, just take half the angle that it intercepts. So it intercepts this entire arc right here. That's 180. Well, half of that is 90. Now, the other thing is the theorem says that if you have an angle and it basically the corners of it at the diameter, then this is 90 degrees. Okay, so A is 90. And I'm going to write that in. Okay, now I've got to find B, but what they give us is this is 50. So if I take my fingers right here and I go out, the angle, the inscribed angle is this angle right here. Well, the angle is half the arc. So what's half of 50? 25. All right. And now we can look at it and say, okay, a triangle. How much is a whole triangle? 180. All right. So if I take 180 and I minus my 90 degrees and I minus my 25, all right. So 180 minus 90 minus 25, we end up with 65 as our answer. All right. So angle B is 65. All right. Now you may be able to go about it another way because here, if that's 180, this is 180. Okay, so 180 minus 50 gives us 130. All right, so B is an inscribed angle of 130. And if you just take half, you get B, which is half of 130 is 65. All right, now in number 8, I got to find the perimeter of this entire figure. All right, now I've got some things and I noticed just like in number 6, you have tangents. That means these segments are equal. So like if this is 7, this is 7. Okay. If this is 5, this is 5. All right. But do you notice how the whole segment is 7.5? So if I take 7.5, and the reason why I have to find what this little segment is because I have to figure out what that is right there. Okay. So 7.5 minus 5 is 2.5. All right. So that little part is 2.5 right there. Now, this is 5, so that's 5. And when the whole segment's 11, so 11 minus 5 leaves me with 6. All right. And so therefore, this is 6. Now, forgo all like the 11 and 7.5. I would just add up all these little segments, and then you've got the perimeter of the entire thing. All right. So 6 plus 6 plus 7 plus 7 plus 5 plus 5 plus 2.5 plus 2.5 plus 5 plus 5. And 6 is where I started from. Okay, so the perimeter equals 51. All right, so remember the rules about tangents and segments. All right, moving right along. Now, this one, number 9, is actually very similar to number 1. Here, we're trying to find this. This is where the question mark is. So I'm just going to put X there for the missing segment. So 2 times 10. And then X times 4, or 4X. All right, this is 20 equals 4X. And I divide by 4, and I get X to be 5. All right, just make sure what's the length of the missing segment. Missing segment was that. So yes, it's 5. Again, always go back to the question. All right, now in number 10, what is the value of X and Y in the figure? All right, so here, anytime you have an inscribed quadrilateral, the two angles that are across from one another equal 180. So X and 112 equals 180. So if I take 180 and I minus 112, I get 68. Okay, that is the value of X. All right, and then the same thing here. These two right here, the Y and 81, are supposed to add to 180. So if I take 180 and I minus 81, so 180 minus 81, you get 99. And that is going to be the value of Y. And if you add all these angles together, they should all add up to 360. Because all the angles in a quadrilateral add up to 360. All right. Now, number 11. number 11 right here. Write an equation of a circle with center -2, 5, and a diameter of 12. Okay, now first off, what is the equation of a circle? X minus h squared plus y minus k squared equals r squared. Remember, the two things you need to know are the center, which is hk, and notice there's a minus right here. So it's kind of the opposite, all right, when you put it in. And then you also need to know the radius. The radius is r, but notice that it's squared out here. All right, so here we go. We have the center. Okay, so when I plug it in, remember, do the opposite. So if that's a -2, we're putting a +2 and then squared. And then the y is 5. So we're going to say y minus 5 and then squared. And then the radius. Notice they give you the diameter. Okay, when a picture has a diameter, it has the whole thing across. Make sure you find the radius. So the radius, half of that is going to be 6. So we put 6 squared. All right, which is actually going to be 36. So x plus 2 squared plus y minus 5 squared equals 36. All right, so here is the equation of our circle. You can also do this. Equations of circles, you can plug this into Desmos. So I'm going to go plug in my answer and just double check everything. All right, so if I put in x plus 2 and then squared, all right, and then, whoops, put plus in between the two, and then y minus 5 squared, and I put in equals 36. Circles, it comes up. Okay, now I'm going to zoom out once so that every square is only worth 1. So let's double check this. Okay, the center, they told us, would be -2, 5. And if I put that in, doesn't that point look like it's the center of it? All right. Also, the radius should be 12. All right. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right. So everything works with what they gave us. So make sure equations of circles, you check it in Desmos. All right. Moving right along. Okay. Okay. So not that problem right there. Let me get situated. Let's go to number 12, another equation of a circle. All right, so this one, name the center and radius of the circle, then write the equation in standard form. All right, so what I'm going to do is I'm going to go ahead, put this into Desmos, okay? We can do it one of two ways. We can, well, actually, let's complete the square first. Let's complete the square, and then also I'll plug it into Desmos in case you can't complete the square. When you complete the square, I like putting the x's together. So x squared minus 6x plus something, because that's what I'm completing the square on, plus y squared plus 4y, and then plus something. Now, if my constant was on this side, I would move it over, but it's already there. Now, notice on the left-hand side, I'm going to add 2 things. So I got to add 2 things on the right-hand side. All right. And when we complete the square, we take half. Half of -6 is -3. I like to put -3 squared here, but -3 squared is 9. So I'm basically adding 9 to each side. Okay, 4, when I take half of 4, it's 2. So I'm going to put 2 squared, but 2 squared is 4. All right, so when I write this, this is going to be x minus 3 squared plus, okay, here, y plus 2 squared. And the reason why I don't actually square this out is because the -3 goes here. 2 goes there. All right. And then equals, and add that together. That's 15 plus 4 is 19. Okay. So now we're going to name the radius and the center. Now here, remember the center comes from these. Think opposite. All right. So if that says -3, then 3, that says +2, I'm going to say -2. This is the center. All right. Now, the radius, unfortunately, this isn't a perfect square right here. Remember, this is r squared. Okay, so to figure out the radius, we just take the square root. So the square root of 19 is our radius. All right. So when I go to Desmos on this one, I'm going to plug in the entire thing, what they gave us. All right. X squared, oops, not parentheses, x squared plus y squared, okay, minus 6x plus 4y equals 6. All right, so we see the circle pop up. I'm going to arrow out. Now, we can kind of estimate where the center is. It looks like it's right here. So that looks like at negative 3, 2. So if I actually put this in negative 3, 2, whoops. And you can even click this and label it. Ooh, nope, that wasn't my center. It was 3, negative 2. I'm sorry. I said the wrong thing. 3, negative 2. And look, it's right there. And if you hit label, you can actually see it labeled with the actual numbers. And that looks like the center. Here's the only problem with this. We cannot count the radius. We can see that it's 1, 2, 3, 4 boxes in a little bit. So it's going to be 4 point something. It doesn't look like quite 4.4.5. But when I did completing the square, do you see how I got square root of 19? So this is one you do have to complete the square to get it exact. All right. But if I look 4.35 or 36, that looks like it could be it right there. And so we think that's it. But the problem is without completing a square, you can't get the full or the exact value of the radius. All right. Now, you can also, when you plug in, now my answer that I got was x minus 3 squared plus, and then y plus 2 squared equals 19. All right. Do you see how when I take this purple one off, the red one's underneath? So I know I wrote the equation correctly. Had I wrote, let's just put like 20 in here. Okay. Do you see how that's actually, I'll do 25. Do you see how it's not the exact same thing? So I knew I did something wrong. Okay. Because it's not overlaying that red one right there. All right. So be familiar with equations of circles, graphing them, finding the radius, finding the center of it as well, and the standard form of a circle. All right, moving on to number 3. The radius of circle P is 12. So here, both of these are radii right here. So both of these are 12. All right. If segment RS is 15, so this is 15. All right. What is the length of PS? So what's the length of this in the middle? Now, anytime you have a radius and a tangent, okay, know that this is a right angle right here. And what can I use to solve this? If you said Pythagorean theorem, you're correct. Now, remember, the two legs are the ones that make up the right angle, that create the right angle. So I'm going to put 15 squared plus 12 squared. And then on the other side is the hypotenuse. This is going to be PS. I'm going to put X right there. So X squared. All right, make sure you square these out. So take your calculator and actually put in 15 squared plus 12 squared. All right, and that's 369. All right, and how do I get X solved for? I take the square root. All right, so in my calculator, to get the square root, you say second and X squared. We say 369. It's not a perfect square. I'm just going to round to the nearest 10th. So when I round to the nearest 10th, what is that? 19.2. They may leave it as a radical or they may put it as a decimal. All right, moving right along. Okay, number 14. A pizza has a diameter of 12 inches. Okay, if you want to draw a picture, you can. That's 12. So what's the radius? 6. So each of these are 6. All right. If the pizza is divided into 8 slices. Okay. So think about this. This would be 4 slices. All right. Like that. All right. So I got 8 slices. What is the length of each pie crust? Length, arc length. All right. So here, when I'm talking about arc length, so I'm just talking about length of one of these. All right. You have to have the degree. Now, when I talk about arc length, think length as part of circumference. Circumference is 2 pi r. But I just want a part, so it'd be like n over 360. Now, we can find the degree of this real easily, okay, because what do you know a circle is? 360. And if I take 360 and I divide by 8, that's 45. What that means is each of these is 45 degrees. So I say 45 over 360. And then 2 pi, and then the radius is 6, like that. Okay, so let's round this to the nearest 100th. Round it to the nearest 100th. Now, if they want it in terms of pi, just put in all the numbers, okay? But because to the nearest 100th, I can just put everything into my calculator. So 45 divided by 360, and then 2, do pi, second caret symbol, times 6. All right, and I get 4.71. All right, 4.71. That is the length. So length is just talking about the length. If I was just going to take a measuring stick and I would measure it. All right. Now, in number 15, notice the difference between this one, number 14, and let's see, and number 5. 14 and 5 I did with degree, okay? But this one is with a radian measure. Okay, so let's talk about arc length first. Okay, what is the formula? The formula for arc length is the radius times the radians. And you can write this formula several different ways. So here in this case, the radius is 10, all right, and the radians is pi over 4, okay? And if I write this in terms of pi, all right, that's going to be 10 pi over 4, but you can take a 2 out. Or if you want to know how to reduce this, if you just put 10 divided by 4 in here, you can hit math, enter, and it's 5/2. All right, or a 2 comes out of those. So this is the arc length right there. Now, the formula for the area of a sector with radians, okay, so area of the sector is whatever theta is, the radian measure, r squared divided by 2. Okay, so here, pi over 4 times the radius squared, and then you divide by 2. Okay, so if we leave it in terms of pi, now what I want you to realize is this is 1/4 right here. Okay, so you can do 1/4, write it like that if you want, and then times 10 squared. That's the top. Okay, so that's 25 pi, and then divide by 2. Now 2 doesn't go into 25 evenly, so I just leave it like that. Now another way you can do it is, all right, if you have 1/4, okay, times 10 squared is 100, and then I divide that by 2. But again, 12.5, so math, enter, and 25 over 2. Okay, so make sure you know the two formulas, the arc length formula and you know the area formula when it's given in radians. All right, now find the value of x. Notice this is an angle on the outside. Okay, you do the far arc, so 220 minus the close one, 54, and divide by 2. And I actually have these two arcs, so I'm good. And so when I throw that into my calculator, 220 minus 54, and I divide by 2. I get 83. So this is the value of x. All right. And I encourage you to go over these again and actually do some of these problems by yourself and see if you can get the correct answer. All right, now moving right along. The other thing we talked about in this unit is points of concurrency. All right, we got 3 that we're going to be tested on: the centroid, the incenter, and the circumcenter. All right, now which one is this right here? Now, if you notice, each of these segments, we go from a vertex, and then these are congruent. This is created by medians. Okay. But which point of concurrency is it? It is the centroid. So centroid and medians go together. All right. Now right here, notice we have angle bisectors. Okay, angle bisectors. And when we have angle bisectors, the point of concurrency is called the incenter. You got to memorize this. All right, you got to memorize what they look like. You got to memorize what goes with what. Now here, this is a little different. Okay, here, do you see how the side is the same distance? Okay, it's the same distance. And so here we can actually draw a circle. And these are all radii of the circle, so they're all congruent. And when we can draw a circle in the inside, it is called the incenter, that point. So again, the incenter is created by angle bisectors. All right, now here, anytime this distance from the vertices to our point of concurrency is the same, we can draw a circle on the outside. And when we can draw a circle on the outside, that is called the circumcenter. And when we have the circumcenter, that is created by perpendicular bisectors. Okay, perpendicular bisectors. Perpendicular bisectors are the ones, they don't have to come from vertices. They come straight down at a right angle. And what happens is they split these sides. All right. And so you would do that 3 times from each of the sides, and they would all meet at this point called the circumcenter. All right. Some more questions about the points of concurrency. So let's go to 18. Now, this is called the centroid. So one of the things you have to know about the centroid is this segment right here. Okay, this is 2/3 of that segment. But if you take half, and notice which one's bigger. The bigger one is from the vertex to the point. And so if you take half of that, which is 3, that's going to be the length of CM or MC. All right. Well, the centroid is created by medians. So when I have a median from here to here, these two segments are alike, or from here to here, that's going to be equal to that. And then this is going to be equal to that. So when I'm looking for MY, if this part is 15, then that's 15. All right. And now 19 is kind of, and some of these questions are kind of going back to some of these figures that are above. What point of concurrency is equidistant from the vertices? All right, that's this picture right here. Okay, equidistant from the vertices. So circumcenter. Okay, what point of concurrency is equidistant to each side of the triangle? That's this one right here. This is the same distance. And we talk about distance to a side, it's going from the point to a right angle. All right. And that is called the incenter. Now, last one. Remember from when we first talked about these, which points of concurrency cannot be outside of a triangle? That is going to be from the centroid and the incenter. Okay, those cannot be outside of the triangle. A circumcenter can be outside of a triangle. And if your class talked about orthocenter, we're not really tested on orthocenter, but orthocenter is created by altitudes. The orthocenter and circumcenter can be outside of a triangle, and those would be on the obtuse triangles. It could be outside. All right. Make sure you review. Make sure you remember the formulas for arc length and area of sectors of circles. And make sure you review through all the theorems that you've got for circles, as well as make sure you know the standard form of a circle as well, and being able to plug it into Desmos.